Okay, we're starting chapter 3 today. We'll start with a little bit of exponential rules that will show up throughout chapter 3, and then start the first learning target at 3:1. All right, so here's some properties that you should fill in. I'll quickly go through them, pause if I'm going too fast. Anything with zero power is always 1. Whether it's a variable or a number, it's always 1. Okay, our negative exponent rule says this. If it's raised to the negative n, it's equal to 1 over a to the n. And both of them are negative. They just kind of reverse roles. The b to the negative n, which is the bottom, goes up top, change it to a positive, and so on. Multiplying powers at the same basis has come up quite a bit this year. X to the third times x squared was x to the fifth on your last test. Add them. Okay, dividing powers with the same base, we subtract in this scenario. So m minus n. Okay. All right, next rule is a power to a power. So when that happens, we multiply the exponents. When we have a fraction being raised to a power, we raise the numerator and the denominator to that power. Okay, this last one is converting from radical form to rational form. So the rule to remember, the roots always goes to the denominator. So if it's a cube root, we're going to put 3 down there. Whatever, square root, put it 2 down there. Okay. All right, so I'll take you through some evens and you can try some odds. Here's the first one. 3 to the negative second, using this property right here. So the answer is 1/9. Here's 4, power to a power. Again, I'm going to go quick, so you just pause if it's too fast. We multiply in this scenario, and then we have the negative exponent again. So 1 over 2 to the fifth, which simplifies to 1 over 32. 6. We have both these rules going on. A fraction being raised to a power, so top and bottom, and then we got to multiply the exponents. So we get negative 4 here. Bottom, negative 6. Flip spots. And then go to your calculator and calculate what these are. Okay. And here's 8. Now we have multiple things raised to the third power. All of these need to be raised to the third power. So that produces this result. And then a to the negative 6 still needs to be addressed. That needs to go in the denominator. So there's the final answer. Okay, pause the video and try 1 through 11 odd, and then I'll give you some feedback on that. Okay, here's your feedback on the odds. So here we go. 2 to the negative third. So 1 over 2 to the third. 1/8. 3. Raise both of them to this negative exponent. So we get 1 in the negative second, 4 in the negative second. Switch spots. So we get 16 on top and 1 squared on the bottom. 16. Here's 5. 5 to the third, 125. 7, multiple things now. So raise them all to the fourth power. So 2 to the fourth, p to the 12th, q to the negative 8. So q to the negative 8 is, remember, 1 over q to the 8. So that's why that needs to go down here. Okay. Here's 9. Two of these now have negative exponents, so the 1 over 5 squared, or 1/25th, needs to be down here. See the negative 4th down here. Okay, I didn't see one quite like 11. I just wanted to see how you do with that. Remember, just a multiplication of 6 things, so you can really just rearrange this however you want. So for example, I could do 5 times negative 3 times x to the negative 5th times x to the negative 1st times y to the 4th times y to the negative 4th, just to turn it into a bunch of little mini problems now. Because 5 times negative 3 is the negative 15. Here I add those together, get negative 6, and this gives me y to the 0. Now you don't have to do that every time. I'm just showing you a way to mentally approach it. And now I can put this in the bottom, right? I really broke this down into fractions for you. I wrote negative 15 is negative 15 over 1. That is 1 over x to the 6, and then this is just going to be 1. So that's what we get for the final answer for 11. A bit of a tougher problem there. Okay, let me walk you through 13. And have you try maybe 15 to wrap up this side. All right, when you have multiple division problems, treat it just like you did on 10 and 11, like multiple multiplication problems, right? So just take it one at a time. 14 divided by 2, what can we do with that? 7. What can we do with m to the 9th over m to the 4th? We can subtract these exponents as the rule states above. So that's m to the 5th, and here I get 0. Anything to the 0 power is 1, so that would be our last step for 13. Okay. All right, so I'll let you try 15, but here's my advice for a problem like 15. Simplify it first before you square it. You could square it first, but the numbers get kind of big. So simplify the inside of 15 like we just did, then square it. Go ahead, pause and try it. All right, so here we go. If we just break this down, 24 divided by 3, we end up with 8. Subtract these, we get negative 6. Subtract 14. Now square them. So we get this. I did 2 different ways to do it. I mean, I could square right away too, but then these numbers get pretty big, but we'll still get the same thing. All right, r to the negative 12 still needs to be addressed. That goes in the denominator, so here's your final answer. Okay, when you're done fixing that, turn the page. Next page deals with radicals to rational exponents and vice versa. So because of that, I rewrote this property at the top. You might want to do that too, just so you have it right in front of you. So whatever n is, the roots goes in the denominator. Okay. All right, so it's asking us to do 2 things here. Express as a radical. So it's in this form right now, right? This is the 1/4. Okay, so if that's the 1/4, where should I put the 4? Right here. So I'm going to write that as the 4th roots of 81 to the 1st power, or just 81. And then you just use your calculator at times if you can't do this in your head, which some of the numbers get big. I get it. The 4th root of 81 can be simplified. It's 3. So here's the answer. Okay, as a radical and simplified. Okay. 18 is just like it. So let me jump down to number, let's try 20. Now, when you have a negative exponent, I recommend taking care of that right away before we convert it, just because this rule doesn't have a negative in it. They're positive, so let's go ahead and fix that right away. So this would be equal to 1 over negative 64 to the positive 2/3. Okay, now I'm going to go ahead and convert it to a radical form. So we've got a radical. We're going to put negative 64 in here. Now I just got to figure out what to do with the 2/3. 3 is the index or roots. 2 stays the exponent. All right, so there it is as a radical. But then I'm going to go ahead and simplify this. I'm going to square 64. No, I don't have that memorized. I already have it written down though. It's 4,096. And then I don't know if you know how to do multiple roots in your calculator, but let me show you how. There's a button under your math option. So math is in the left-hand row of your calculator. And the 3rd root is there, but we may do 4th roots, 5th roots. So let me demonstrate that button for you right now. So if I hit that button, I can type over that and put in any root I want. So I'm going to take the 3rd roots of 4,096. It gives me 16. So this is equal to 1/16. Okay, go ahead, pause, try 17, 19, and 21. Okay, here's your feedback on 17. Convert it. Check to see if the right placement of these numbers. That's key. And then do what you can to simplify it. So we end up with 9 for the final answer. 19, it's a negative exponent. So just like we did in 20, you address that right away. And now your conversion just stays in the denominator. So we got the square root now. So if you don't want to write 2 right there, you don't have to. If it's invisible, we assume the square root. 1/27. And the last one, 21. So it's a little confusing because of the fraction, but just focus on keeping that number. Put these in the right spot again. Third root and to the 5th power. Then grab your calculator to help. Okay, I just did 8 to the 5th in my calculator. It gave me this big number. Remember, you can change things back to fraction form too. So if you have a multiple choice and decimals aren't there and they're fractions, what should you do with this? Let me show you. Cube root of 1 divided by 32768. That's a decimal. But if I hit this math button again, it gives me a change it back to fraction option, which is very handy. Hit enter, and it would do that for me. 1/32. Okay. Okay, let me take you through just a couple more. I'm going to do 22 and 24 for you. You're going to try 23, 25, and we'll do one more thing in 3.1. Okay, now we're going the other way around. Now it's a radical, and we're going to write it as a rational exponent. So we're going from here to here. Okay, so we're going to write this as x raised to the 12 over the roots, so 12/4, which can be simplified to x to the 3rd. 24, we're doing the same thing, we're just doing it 3 times. So to make that clear, if you want to add this step, it means we're going to do the 5th root of 32, we're going to do the 5th root of x to the 15th, and we're going to do the 5th root of y to the 4th. Once you get used to it, you don't necessarily need this step. But now I'm doing 3 of those problems. So 32 has an exponent of 1, so it's 1/5. This one's going to be 15 over 5. And this one's going to be y 4/5. What can we simplify? 32 does have a 5th root. It's 2. So I've got 2. This reduces to x to the 3rd power. Y, I'm going to have to just keep it as a fraction. Okay, you try 23 and 25 to wrap it up. 23, 24 over 8, so d to the 3rd. 25, multiple ones again. You could do it this way too. You could realize that this is just all square root and raise it all to the 1/2 power and then do power to power. That's one way to do it. Or we can break it down piece by piece and do it this way. So I got the square root of 8. It doesn't have a perfect square root, so you might just want to leave it as 8 to the 1/2. All right, here I got 4 over 2 and 16 over 2. So there's the final answer. Okay. All right, and we're going to take a look at the first learning target of 3.1, graphing these exponential functions.